Hi, everyone. My name is Mykesha James. I'm a graduate student at McNeese State University. I'm also a school teacher in Louisiana, teaching third grade students all subject areas. Today, we're going to be multiplying using arrays. Let's start by playing a little game. So I want you to gather around some family members or a few friends who's ever near. And I'm going to call out a situation. If you have done this, you're just going to pop up one finger. At the end, you can just celebrate how many fingers you have popped up. Have you ever arranged small toys in one room, then made more rows with the same, have you ever arranged toys in one row, then made more rows with the same amount of toys as that first row? If you have, you pop up one finger. How about make cupcakes in a muffin pan? Have you ever baked cookies on a cookie sheet with an equal number of cookies in each row and column? If you've done any of these, then you have some background knowledge for what we're going to get into today. The learner will recognize an array, use arrays to model multiplication, and use arrays to solve various multiplication problems. First, we're going to begin the lesson by discussing key terms that are important for the lesson. I will model representing a number sentence with an array. I will guide you through representing a certain situation with an array, and it's actually a few situations so that we get some good practice. And then we'll review key concepts to make sure that we really understand the purpose of an array and how to use it with multiplication. Okay, key terms are multiply. Multiplication is basically, and it is, repeated addition. An array is an arrangement of objects, pictures, or numbers in columns and rows. A row is an arrangement of objects in a horizontal line, or those objects are side by side. That's a row. Column is when the arrangement of objects are in a vertical line, or those objects are one above the other. A number sentence is a mathematical sentence made of numbers and signs. Factors are numbers that are multiplied together. A product is the answer when two or more numbers are multiplied. And commutative property, which we won't get into in depth, but I will introduce it. It's when you can swap around two factors or more and still get the same answer. So I'll be using this academic language throughout the lesson. If you forget, you can always pause or rewind the video just to refresh your memory to this screen. Okay, I'm going to model using an array to multiply 2 times 5. The purpose of this tutorial, just this right here, when I'm showing the array for 2 times 5, I'm not going to actually tell you what 2 times 5 equals. I'm just going to represent that with an array. This 2 is going to represent the number of rows in my array, and the 5 is going to represent the number of columns in my array. So I'll count it out here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I have constructed my array. I have 2 rows, and I'll use a pen here just to show you the rows. Here's 1 row, and here's my 2nd row. So I have 2 rows. The rows are represented by this number 2 here, one of the factors. And 5 is represented with the columns. 1, 2, 3, 4, 5. And so I would say that I have a 2 by 5 array. This entire figure, without the lines, just the objects, the triangles, was my array. It's the way I organized those objects. 2 rows of 5 objects. Now I'm going to do the same thing with 3 times 4. Can you talk to your family members and friends about how a model could help us to solve multiplication problems? How can a model help us to solve multiplication problems? Okay, and here is one strategy for doing so. It's an array. Here we have 3 rows and 4 columns, or you can also read these situations as 3 rows of 4 objects. 3 rows of 4 objects, and that's how I'll count in here. So I have 1 row of 4 I'm about to count. 1, 2, 3, 4. I'm going to make a second row of 4 objects. 1, 2, 3, 4. And finally, my third row of 4 objects. 1, 2, 3, 4. The entire arrangement here is called an array, and it's a 3 by 4 array because it has 3 rows and 4 columns. So we will call this a 3 by 4 array. Now you can get your sheet that came along with the video, and you can follow along to try and construct some arrays with me in some different situations, or if you just want to use loose leaf or plain copy paper, that will be just as sufficient. Miss Zoomer was one of the staff members parking cars at the party. She parked 2 rows of 7 cars on the blacktop. We're going to draw an array that represents Miss Zoomer's parked cars. Use an X to show each car. So at this time, I would like you to try and do that. You can pause the video, set a timer for 2 minutes, or just look at the clock. 2 minutes of think time for you to construct that array. And X represents the car. Okay, key information in this problem, which is an important, what happened here? Let's see. Let's see. We are here and there. Okay. Something important to do with math word problems are to mark out that key information. A strategy I like to use is RDW, which stands for read, draw, write. And since we've already read, I'm going to put a check there. Draw is when you draw a model to represent what's happening in that problem, the key information. So Ms. Zoomer was one of the staff members parking at the party. We wouldn't draw her like parking cars. That's not going to be important for this math. But she parked 2 rows of 7. I'm seeing numbers here that are important for the situation. So those are the types of things that we're going to draw. Did you draw an array that looked like this? 1, 2, 3, 4, 5, 6, 7, and then a second row? 1, 2, 3, 4, 5, 6, 7. If you did, give yourself a round of applause. And so I'm going to check off the D here because I did draw something. Thinking about that question earlier with models helping us to, or an array in particular, helping us to solve multiplication problems. Are you seeing how this could probably help us solve anything yet? Ms. Zoomer adds 2 more rows of 7 cars on the blacktop. We're going to use circles to show the new cars on the array, like in part A, which I have pasted here for us. This is what we finished with in part A. And now Ms. Zoomer adds 2 more rows. So you can pause the video and try and draw what you think that might look like. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Is that what you drew on your paper? So we have 2 rows of 7 cars from the first parking, and she parked 2 more rows of 7 cars, which are represented by the circles. We're going to fill in the blanks below to show how she added the 4 rows. So we have a total of 4 rows. Let's talk about how we got to these 4. How many 7s did we have with the first parking? Let's see the X's. There's 1, 7. And by 7s, that's our unit. That's the number of objects that were in that row. And 2 7s. So we have 2 7s plus how many more 7s did we get when she added the new cars? 2 more 7s. Represented with the circles. There was one group of 7 and another group of 7. So we have 2 7s plus 2 7s. How many total 7s do we have? Can we count? That's 1 7, 2 7s, 3 7s, 4 7s. Awesome. Now we're going to find the total number of cars Ms. Zoomer parked. When I say total, what strategy are you thinking that you could use to determine the total number of objects here in this array that we've made? Okay, I'm thinking we can count all of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So there are 28 total cars, and I got that total from counting them. Some other things you may have tried were or thought about was adding 4 7 times, like 4 plus 4 plus 4 plus 4 plus 4 plus 4 plus 4, or adding 7 4 times, 7 plus 7 plus 7 plus 7, or a more efficient way for that repeated addition is multiplication. If you're adding 7 4 times, that's simply, or if you're adding 4 7 times, that can be written as 7 times 4. We have 7 4 times. 1 group of 7, 2 groups of 7, 3 groups of 7, 4 groups of 7, which all equal 28. Now here's where that term commutative property that I showed you before the lesson. If we swap the 4 and the 7, do you think we would get the same product, this same 28? If I had 4 times 7, are we going to get the same answer? Yes, we will. Go ahead and pause the video. Talk to your friends around you about why that might yield the same product. Why do we get the same product when we swap those factors? And you can use this array to help your explanation. Okay, 4 groups of 7. So I'm counting the rows. There were 4 rows of 7 was 28. And 7 groups of 4 was 28. Okay, now let's try another situation. Ms. Zoomer parked 12 buses at the party. She parked 4 buses in each bus circle. We're going to draw Ms. Zoomer's bus circles. Her bus circle in this situation can be a row or a column. Okay, you can try that one. right? Are you starting to draw something that looks like this? 1, 2, 3, 4. That's 4 buses in one circle. And she had a total number of 12. So part 12, that's the total. And 4 buses in each. I'm going to keep counting on until I get to 12, but I know that I can only have 4 buses in each circle. So I can just do this as one circle, and I'm going to make sure that each circle, which in this case is a row, only has 4. I've counted up to 4. I'm going to count 5, 6, 7, 8, 9, 10, 11, 12. So do you see how I arranged them in rows of 4? Each row has 4 objects in it because there were 4 buses in each circle. I stopped at the number 12 because she had a total of 12 buses parked. So right now we have a 3 by 4 array. If your circles were columns instead of rows, you may have had objects like this. 1, 2, 3, 4, and you had one bus circle as this column and another bus circle as this column, and these aren't perfect, but that's the idea here, is the other kind of array you could have constructed from this situation. So the question here is, are we getting the same total? Yes, there are still 12 total objects in each array. Here's a 3 by 4 array. Here's a 4 by 3 array. They are both correct. We're going to write a multiplication sentence that describes our drawing from part A. So here it is. I've pasted it here on this one. We have 3 rows, 1, 2, 3, and 4 columns, 1, 2, 3, 4. Do you think you know what the multiplication sentence might be? Very good. 3 times 4 equals a total of 12. All right, so hopefully you enjoyed those situations. Let's review. A row is when objects are horizontal, they're side by side. A column is when objects are one above the other, they're in a vertical line. An array is when you have objects that are arranged in rows and columns. So we have straight lines across, straight lines down with those objects. And a multiplication sentence is when you have numbers and symbols in an equation or a number sentence. You have numbers and symbols to make a sentence. Arrays can be used to model multiplication problems, and we saw that they can also be used to solve those multiplication problems, not just model them. Thanks for watching. There is an assessment provided.